Okay, so in exercises 1 through 4, classify the polygon by the number of sides, and then tell whether it is convex or concave. So to start, we're going to count the number of sides. You can count the sides themselves. I count the corners because however many corners there are, that's how many sides there are. So you've got 1, 2, 3, 4, 5. Five-sided polygon is called a pentagon. Feel free to talk to the video, just like you would in class. In number 1, we want to decide if it's convex or concave. So again, convex, all of these segments point away from the center. Concave, some of them will point towards the center. So what you'll look for are segments that come in towards the center, which makes this one concave. Number 2, again, we're going to count the corners. 1, 2, 3, 4, 5, 6, 7, 8. So an 8-sided polygon is called an octagon. Then you want to compare and see if any of these sides come towards the center. None of these do. They all pretty much stay around it. So this would be convex. Number 3, 1, 2, 3, 4, 5, 6, 7, 8. So again, 8-sided is going to be an octagon. And then convex or concave, some of them do come inwards towards the center, which makes this concave because some of the sides cave in. And then last, this one's a rather large, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we talked about this yesterday. You do need to know the names of the polygons based on their sides all the way up to number 12. So number 12 has the prefix do, which means 2, and then decagon. So dodecagon. And then convex or concave, none of them come inward towards the center. They all pretty much stay away. So this is convex. We are going to be finishing our 1.4 notes, so you should be on page 3, and we'll be on the second example under example 2. And it looks like this. The directions above said finding the perimeter in the coordinate plane. So you have 1, 2, 3, 4 points. So this is going to be a quadrilateral of some sort, so keep that in mind. So we're going to plot all the points. So go ahead and draw an X and Y axis. And then we're going to plot the points. We've got -1, +1, so -1 means to the left, and then +1 is up. So there's K. For L, we've got +4, so from the origin that's over 1, 2, 3, 4, and then up 1. M is 2, -2. And then the last, we've got -3, 1, 2, 3, -2. So we have a parallelogram. So in this shape, we've got quite a few things happening. So perimeter, we want to add all the sides. So remember that if it was a horizontal or vertical line, you could count. I had you write this down. If it was a diagonal, you use the distance formula. So we do have 2 horizontal lines. We've got the top and the bottom are horizontal. So you count the boxes, 1, 2, 3, 4, 5. And then the bottom, 1, 2, 3, 4, 5. So the only thing that we don't know would be the length of Kn and the length of Lm. So we are going to find the length of Kn. So the only two points we should be looking at are K and N. You don't have to cross out L and M, but we want to be only looking at K and N. That was a very common mistake that I saw when I was walking around the room grading your classwork from yesterday, was people plugging in the wrong points. I don't need to know the length of KL because the length of KL is 5. So if you use point K and point L, you're going to find the length is 5, and we already knew that. We want to plug in the points that we don't know the length. So we're going to use points K and N so we can find the length of that line. I always write the formula with blanks so that I can just plug straight in. I'll give you a second to do that. We can also label the points that we are given. So K, which would be x1, y1, and then N would be x2, y2. All right, so we're going to plug in my first x, which is -1. We'll plug in my second x, which is -3. This is why I write the formula with blanks, because when I plug in a -3 and there's already a negative there, I know that's going to turn into a positive. Then we're going to plug in our y's. The first y is 1. My second y is -2. So again, I'm plugging in a negative. There's already a negative in the formula, so I'm going to put a plus sign. -1 plus 3 is 2. 1 plus 2 is 3. 2 squared is 4. 3 squared is 9. So we get the square root of 13, which is equivalent to 3.6. So we did all of that to find the length of Kn, which is 3.6. Okay. So this is a parallelogram. I know it's a parallelogram because it's got two pairs of parallel sides, which would be KL and NM. So KL and NM. They're parallel, which means Kn is going to be congruent to LM. Kn is going to be congruent to LM. If you are unsure, you're taking the test and you're not sure, you can always just plug this into the distance formula, L and M, and they will equal. So knowing that, the length of LM is 3.6. Okay, so to find the perimeter, we are going to add all of the sides. So the perimeter will be 5 plus 3.6 plus 5 plus 3.6. So that makes 17.2, and then you would write units. Perimeter is 17.2 units. Okay, so now we're going to talk about area. So when we talk about area, we're talking about what is inside of a figure. You've seen these formulas before, so we're going to talk about them. The first one is a square. What makes a square is the fact that all the sides are the same length. So a square's formula is side squared. So whatever the side is, it's squared, the side times the side. A rectangle is going to be area equals length times width. Length times width. So length, width, okay, it doesn't really matter. Length, width, you're just multiplying those two together. And then the last, students forget this one every single time, and I do not understand. This is a triangle formula. You'll need to know it for all of geometry, so it'd be best to learn it now. The reason I say this is it is 1/2 times the base times the height. It is 1/2 base times height. I would write this down. You've got room in the bottom right-hand corner. Area equals the base times the height. So when we're talking about the height will always be from the very bottom to the very top of the object. So from the very bottom to the top. And you think, Miss Marshall, that's dumb that you have to write that. Some triangles will be inverted. Inverted means upside down. So the height is from the highest point of the triangle to the very lowest point of the triangle. Okay? Usually it's in red if it's in a textbook. Okay? You'll also see this right angle. The reason being, and the height will always be sitting on the base. So if you had an inverted triangle, wonderful drawing from me today. And that this was the height, the base would actually be up here. I know a lot of people think the base means the bottom, but it's not actually. You're going to find a horizontal line. The base will look like a horizontal line. We're only in geometry. Obviously triangles can look any which way, but the ones in this class, the base will be in horizontal line, whether that be on the top like I've drawn, or like the picture given, this base is on the bottom. So you're looking for that horizontal line. So to warm up, we're going to do some composite shapes. Remember, composite means there's two polygons added together. So you've got a triangle right here, right? And then you've got a rectangle. So we're going to find the area of both, and since the triangle was added on to the rectangle, you're going to add them together. So we're going to find the area of the triangle first. So area equals 1/2 the base times the height. 1/2 base times the height. So in this picture, okay, if you see this dotted line and this right angle, remember that always is what the height looks like. I know this triangle is kind of turned sideways, but anytime you see that dotted line and that right angle, it's telling you the height of the triangle is 6. Okay, so there's our height. We could plug in. Area equals 1/2. Our base will be the horizontal. Now here, again, the triangle's kind of turned. So what I've done is I've kind of rotated it for you so you can kind of see, kind of see what you're working with. Okay, all I did was literally just turned it. So the dotted line is 6 meters, right? This is the height. The height is 6 meters. Okay, so you can see that. The base, okay, this portion is the base. Okay, everyone can see it. It's going to be congruent, since it's a rectangle, to its opposite side. So the base is going to be 8. And then we said the height was 6. This is multiplication. Doesn't really matter what order you multiply in. I'm going to do 1/2 of 8, which is 4. And then multiply it times 6, which is 24. So that means inside of this triangle is 24 meters squared. We'll talk about it. It's the area of the triangle. Okay, then we've got to find the area of the rectangle. So area equals length times width. So I've already kind of color-coded it for you. The length is going to be 10, and the width is going to be 8. So length and width, 10 times 8 is 80. So the area of the rectangle is 80 meters squared. So we're going to add those two together, and we get 104 meters squared. Yes, you do need to answer in square units. So you could say meter squared or squared meters. It's the same thing. Here is what that means. Area is two-dimensional. So it means you could fit, in my triangle, I could fit 24 square meters of little squares, okay, that are 1 meter by 1 meter. And then in my rectangle, you could fit 80, okay? That's all that's saying. It's easier to see with the graph. We'll talk about it in a second. You'll be able to visualize it better. We'll flip, look at the next problem. This one is very similar. It just doesn't have the line already, like this one had the line. You can draw one. That would probably make your life a little bit easier to visualize. This is like a look at that. It's a crayon. You got a triangle and you've got a rectangle, okay? We can do, right, so we're going to find the area of the rectangle, and we're going to add it to the area of the triangle. That's the goal. That's the end game. So our rectangle right here, okay, area equals length times width. So they gave us the length and the width. 18 times 10, or 10 times 18, it's the same thing. So the area of the rectangle is 180, and it'd be meters squared again, because it's meters. Then we'll find the area of the triangle, 1/2 base times the height. So area of the triangle. So this one is a smidge different because it doesn't give you the height. So I want you to think of how last time the triangle was turned, right? I could turn it for you. No, I can't. I turned it. I figured it out. So I rotated it for you so you could see. The height, though the line isn't there, the height is here. You're going to have to do some deducing there. So think about this. From the very bottom of the crayon to the very top of the crayon is 30 meters. From here to here, where the rectangle is 18. So how much is left for the triangle? Okay, so 18 plus what makes 30? They click in their calculators. 30 minus 18 is 12. So this height is 12. Found the height. The length of the base, most people would try to do 13, and it is not 13. Okay, it has to be the horizontal line. And again, I rotated it for you to make it look a little easier. This would be your horizontal line. So what would the length of this piece be? It's going to be 10. It's going to match the opposite side of the rectangle. So we've got our base and our height, so we're going to plug in 1/2 times my base, which we said was 10, times my height, which is 12. Now we just multiply. 1/2 of 10 is 5, times 12 is 60. So we add these together to get our final answer of 240 meters squared. So we did those two basically to review area. We are going to do this in the coordinate plane, and just like with perimeter, it's not going to be a compound object. It's just going to be either a rectangle, a square, or a triangle. So looking at this one, we've got find the area of triangle DEF with vertices D, E, and F. So you want to first draw your X and Y axis. We're going to plot the points. We've got 1, 3, so over 1, up 3. point D, and then E is 4, -3, so over 1, 2, 3, 4, down 1, 2, 3, E. And then F is -4, -3, so 1, 2, 3, 4, 1, 2, 3. And it is a triangle, so you want to connect the dots. Hopefully do a better job than me. Good enough. Nope. Good enough. So, to find the area, we're going to use the area formula for a triangle. 1/2 times the base times the height. So, the base, remember, is going to be the horizontal line. So here, the horizontal line is FE, okay? So this is a horizontal line. Remember, if it is horizontal or vertical, you're going to count, okay? If it is diagonal, which neither will be here, if it's diagonal, that's when you use the distance formula. Okay, but we're going to count. 1, 2, 3, 4, 5, 6, 7, 8. So the length of the base is 8. And then the height, remember the height is from the very top of the triangle to the very bottom, which in this case, the very top of this triangle is D, and then you'll drop a straight line down. Okay, the reason it's a straight line, think about when you go to the doctor and they measure your height, you have to stand completely straight up against like a wall or whatever their tape measure is. And you're actually make a right angle with the ground. When you are completely straight, vertical, the ground is obviously horizontal, so that's where the right angle comes from. We'll talk about it more in later chapters a lot. But you're going to count the boxes because, again, it's a vertical line. So 1, 2, 3, 4, 5, 6. From here, we just math. Half of 8 is 4, times 6 is 24, and then we're going to say square units or units squared. And here is what that means. It means you could fit 24 little squares inside of this triangle, which, again, if this were a rectangle, would be easier to see. But if you went through and counted 1, 2, 3, 4, how many squares are in this? 5, 6, 7, 8, 9. If you went through and counted, not including these little pieces, you'd have to count them very interestingly. But you would find that you can fit 24 squares in it. I think that will be easier to see on the next one because it is, I think it's a rectangle. So, on the next one, we're finding the area of the quadrilateral. We know it's quadrilateral because it's got, 4 points. But we're going to draw our x and y axis. And then we're going to plot our points, -2 up 1, 2, 3. That's point F. 1, 3 over 1 up 3. That's G. 1, -1. That's H. And then -2, -1. That's J. Again, you'll want to connect the dots. Okay? So, area equals length times width. So again, these are all horizontal and vertical lines. So you're going to find the length and the width of the sides. So 1, 2, 3, 4. You can call this the length. The width, 1, 2, 3. So 4 times 3 is 12, and you again would say square units. Here's where I show you why it's square units. Guess how many squares fit inside of this rectangle? 12. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ding, ding, ding. So that's what you're doing when you're finding all of these areas. You're figuring out how many little squares can fit inside of the area. So you're going to do a classwork assignment that your sub will hand you. If you're virtual, this is available. It will literally be called 1.4 Classwork Area Worksheet. It is due tomorrow. If you do not finish in class, it does become homework, and we will check it tomorrow. I can I can give the sub the answers so that if you finish early or you want to check how you're doing, you can ask and he can check for you. Okay, I will see you guys soon.